Hey, what's up? It's your old pal, Mr. Cook, and we're going to be working on the extra review for Unit 2, Part 3. Don't get distracted by my black fingernails. I just colored them in Sharpie so I could look the part of an e-boy for today's Spirit Day. Anyways, I'm going to go through these problems one by one. We're going to graph these rational functions and find a bunch of stuff that tells us how the graph makes sense. Okay, so whenever you're graphing out your rational functions, always have your graphing calculator handy because it basically tells you exactly how the graph's going to look. So we're going to type in this expression. Make sure that when you're typing it in, you put the top part in parentheses and the bottom part in parentheses. So 3x squared minus 12 divided by x. Graph. And okay, that's how it looks. Now we're going to make sense of all of this, put in the asymptote lines and all of that kind of stuff. So the first thing that we're looking for is the domain, and then the vertical asymptotes, then the horizontal asymptotes if there are any of those, and then slant asymptotes, removable asymptotes or holes, x-intercepts and y-intercepts. So before we start all that stuff up, the best thing to do is to take your original rational function and factor it as much as possible. So if we have 3x squared minus 12, I know I can divide 3 out of both of those terms. So I get 3 times parentheses x squared minus 4 in the top, x in the bottom. And then this is a difference of squares, quadratic, so I can factor that a little bit further. So I get 3 times parentheses x plus 2, x minus 2. And if you don't remember how to factor quadratics, which is, we're going to be doing that a lot throughout the entire review, make sure to maybe go back and watch some of those videos that we did on factoring quadratics a little bit earlier in the year. Anyways, so now that this is completely factored out, I can answer all of these questions really easily. First, the domain. So the domain is always going to be when you take the denominator of a rational function, you know that you can't have that equal to 0. So that means that you take each individual factor of the denominator, say that it can't be equal to 0, and solve for whatever x value that you get. In this case, it's real easy because it's just x, so we just say x cannot be equal to 0, and we don't need to solve it any further. That just is our domain. It's just that one value. From the domain, you will get either vertical asymptotes or you will get removable asymptotes or holes. So here's how you can check for either of them. The holes are the ones that you check for first. That's when you have a factor that's in the top and in the bottom that cancels out. Like if I had x plus 5 in the top and x plus 5 in the bottom. If I had that, then they would cancel out, and whatever other factors that I have left over would be left there. And from this, I would have to write out, this x value that I have, this domain restriction that I have, is actually just a hole in the graph. So like a coordinate that has a hole right there. We'll probably see a couple of those later on, and I'll point those out when we get to them. But in this case, since no factors up here cancel out with x, this is just going to be a vertical asymptote only. So that means that for the vertical asymptote, the equation, we write out x is equal to 0. This is the equation for a vertical line that passes through 0 on the x-axis. So this is really just the y-axis. So that means that that's going to be where our vertical asymptote is at x equals 0. There we go. It's just the y-axis. Pretty easy. Next, we check for the presence of any horizontal asymptotes. Horizontal asymptotes come about from overpowering values on the numerator or denominator. We check those based off of the degree. So always check the degree in both the numerator and denominator. All right, so the degree in the top, in the numerator, is 2. The degree in the bottom, the denominator, is 1. And since the degree in the top is bigger than the degree in the bottom, there is no horizontal asymptotes. However, since there's a difference of 1 between them, so in other words, there's 1 more in the top than there is in the bottom, we will have a slant asymptote. So here's how you find a slant asymptote. All you need to simply do is just ask, do what the rational function asks you to do, and that's to divide this out. So what we're going to do is we're going to divide 3x squared minus 12 by x and see what linear equation that we get as a result. So if I just simply use synthetic division, the factor that we're testing is x minus 0, so 0 goes in the corner, and then our coefficients are 3x squared, 0x, minus 12 for the constant, And then we only care about these two values because this will give us a linear equation. We don't care about the remainder at all. It doesn't matter what the remainder is. So 0 times 3 is 0, 0 plus 0 is 0. Okay, so this gives us a linear equation. Y is equal to 3x plus 0. This is our slant asymptote. It's just y equals 3x. So this is another one of those barrier lines that we get. So we can draw this one out as well. So the equation y equals 3x passes through the origin, so the origin's here. And then the slope goes up 3 over 1. So up 3 over 1, and then down 3, and left 1. So there. Now we can just draw, with a straight edge or whatever you've got on you. There's our slant asymptote. Passes through the origin and has that slope of 3. Now that we have all of our asymptotes lined out, or laid out in front of us, what we're going to do is explain how the graph is going to look according to these asymptotes. Every time that you have a vertical asymptote, it splits up the entire domain and the graph itself into different sections. In this case, we have two different sections that we're going to graph out. One that is to the left of the vertical asymptote, so everything that's to the left of x equals 0. And then one that's to the right of the asymptote, so to the right of x equals 0. So I'm talking about graphing out x values that are like -1 and -2, -3, -4, and so on. And also, that's all to the left of 0, and then to the right of 0 would be like your 1, 2, 3, 4 values. So we're going to graph all of those things out as we see them. The graphs of the left-hand side of the equation and the right-hand side of the equation are very set in stone as to how they're going to look. Like, if I have options for the left-hand side, my graph is always going to follow the asymptote lines if I don't have any middle parts. So for this part, it's just going to look like either this, where it goes along the asymptotes like this, kind of makes like a little J shape, or this shape where it kind of makes like a little lowercase n shape. So that's what the left-hand side of the graph is going to look like, either this one or this one. We're going to get some coordinates to plug in to see how it's going to look. I mean, you can even kind of preview what it's going to look like based off your graph. It's going to look like that. That's not going to be anything particularly crazy. And then on the right-hand side of the graph, it's either going to look like this in the asymptotes or it'll look like this along the asymptotes. Okay, so we got to see which one it's going to look like based off of just some coordinates that we find. So what we're going to do is first find some of those coordinates. So the easiest ones to find are the intercepts, so the x-intercepts and the y-intercepts. And if that's not enough to give us an idea of how the graph is going to look, we're also going to get a couple of test points that we're going to graph out. So let's see if that's necessary by first finding the x-intercepts and y-intercepts. So the x-intercepts are always found from the numerator. All you have to do is just take the numerator, once it's all simplified down, once it's all factored, and set it equal to 0 and solve for your x values, okay? So, we've used the denominator and then the numerator at different points. So the numerator, each factor, so x plus 2 and x minus 2, I'm going to set them equal to 0. So if x plus 2 equals 0, that means x equals -2. So that means that we get an x-intercept at -2, 0. The other x-intercept that we get is from the other equation, x minus 2. We set that equal to 0 and solve. By adding 2 to both sides, we get x equals 2. And therefore, my other x-intercept is going to be at 2, 0. So those are my two x-intercepts. I'm going to graph them out real quick. So 2, 0, 2, 0, 1, 2. And also -2, 0, 1, 2. So I don't know if you've noticed this, but these coordinates that we have are really close to this graph and this graph over here. And if you look on your graphing calculator, you'll also see that those points are right over there. And you can even see the contours of the graph that we're going to be using. So once you have these points in these locations, you can actually pretty much without any type of reluctance just know that that's how the graph is going to pass. It's going to go along the asymptotes. It's going to pass through these points and then follow the other asymptotes. So that's how our graph is going to look. We can get rid of these other options that we had over here. And there's not really any need for any test points because it already kind of outlines how the graph is going to look. We can still find the y-intercept if we could, but if you noticed from earlier, we can't use 0 for our x value, so we can't find our y-intercept. So there is no y-intercept on this case. Okay, so that is the first problem. I'm going to do a video on the second problem in a second.